According to the United States Energy Information Administration, in 2011, the total energy use per capita consumption in the United States was 312 million British thermal units. To put British thermal units into easier terms, 1 barrel of oil has an energy content of 5.8 million British thermal units. That means that in 2011, each person in the United States used an average of 53.79 barrels of oil in energy consumption. In 2009, the U.S. Energy Information Administration said that the United States' primary energy consumption was about 95 trillion British thermal units, where the world was consuming 483 quadrillion British thermal units. This means that in 2009, the United States consumed about 20% of the world's total energy. Solar energy is a great renewable resource because it doesn't deplete any natural resources. It will never run out, and it is environmentally friendly. The United States Energy Information Administration estimates that about 10% of the world's marketed energy consumption is from a renewable energy source. Even though our team was aware of the staggering amount of energy used, we weren't sure what our local community knew. So we went around and posed the question, what do you know about the U.S. energy consumption?
I don't know a whole lot about it, but I know that it's too much and we need to reduce our energy, output, I guess.
Yeah, I don't know anything about it.
Like windmills powering places or like solar energy panels. I don't know anything.
Renewable energy, pretty much. Just like anything that has to do with converting the energy once more and using it in different forms.
I don't have a clue. I think we consume a lot of energy, and we need to shift to renewable energy and try to consume less power in general.
I know that in the average year, the United States consumes more energy than all of the energy that was in the Japan earthquake in 2011.
We think that the George Washington University Solar Charging Unit, known as the UNIT, will be a helpful invention so that students can use an alternative form of energy. It will show our community that solar energy is useful and can easily be incorporated into our current spaces.
UNIT is an outdoor solar energy generator built into the form of a functional table that allows students to charge their cell phones, laptops, and other electronic devices and can power large outdoor events. The panel is so large it will still be able to generate significant amounts of electricity even when some of the panel is being covered by books and laptops. It is also designed to blend in with its surroundings as it is a table and will not stand out in a negative way. Top priority was given to ensure the unit possessed a sleek and clean look. It was designed in a way where it looked professionally built. The unit is completely self-contained as it has all the necessary equipment to convert direct sunlight into AC electricity for electronic devices. Finally, it will decrease GW's carbon footprint and energy costs. Along the length of the unit is a shelf 6 inches in depth made of angled aluminum. These shelves will allow people to place their cell phones and other smaller electronics right by the outlet instead of running their charger wires up over the table. This will also allow more people to charge their electronics as they don't have to be sitting right at the table. The unit is intended to be placed permanently outside and is designed to operate in year-round weather conditions.
There are 23 outlets on the unit, so only 23 devices can be plugged in at once. The following calculations and statistics are based on General Electric's data on the average power consumption of the following devices. A 90% inverter efficiency means 15% of the electricity generated by the panel will be lost in the environment in the form of mostly heat. If the solar unit experienced no sunlight, it would still be able to power any event held in Kogan just on its batteries alone. It could power 23 cell phones for 765 hours, or 31.385 days, or 23 laptops for 62 hours, or 2.55 days, or one small iHome/stereo for 10,054.28 hours, or 418 days, or one LCD projector for 351 hours, or 14.66 days, or 2 1,000-watt speakers, one LCD projector, and one laptop for 31.25 or 1.3 days. We think the unit is a great way to expand solar energy on campus.